and this is 2.1 part 2. So look at this example. Find the domain and range and determine if the relation is a function. So the domain, remember the domain is just the set of all x coordinates. So we have 19, 27, 22, 36. Now you want to put those in numerical order. So when you put them into your brackets, you would have 19, 22, 27, 36. If you do have some that repeat, you just write it down once. How about the range? For the range, we're going to have 2.4, 3.0, 3.6, 2.4, and 3.8. So putting those in numerical order, we have, oh, we don't need this one, do we? We have 2.4, 3.0, 3.6, and 3.8. So now we have our domain and our range. Is this a function? I did notice we had this one right here and this one right here. We have repeating x's with different y's. That means this is not a function. So what if we wanted to map it? You could say 19 is mapped to 2.4, 27 is mapped to 3.6. Oops, I did that wrong. 22 is mapped to 2.4. 27 is mapped to 3.0. 19 is also mapped to 3.6. And then 36 is mapped to 3.8. The reason we know it's not a function is because of this one here. One of our x's is mapped to two different things. It doesn't matter that a y is mapped to two different things. That's okay. You just can't have an x mapped to two different things. So, we've already determined it's not a function. We can move on to the next page. Find the domain and range and determine if these relations are functions. Okay, so for domain, we have -1, 3, and 3. So we just have -1 and 3. For the range, we have 1. Oops, I should go in numerical order. So we have -9, 1, and 9. Is this a function? 3 is mapped to 9, 3 is mapped to -9. This is not a function. What's the domain of number 2? Remember, for domain, what is x not allowed to be? So the 2x minus 1, remember it's under a square root, so it must be greater than or equal to 0. Add 1 to both sides, so 2x is greater than or equal to 1. Divide by 2, so x must be greater than or equal to 1/2. This will be your domain. You would write it like this. The domain is all real numbers such that, or given that, x is greater than or equal to 1/2. So what about the range then? Well, you're limiting what your x can be. If x is 1/2, this will be 2 times 1/2, which is 1. 1 minus 1 is 0. Square root of 0 is 0. So we know that your range is going to start at 0. But does it go bigger than 0 or smaller than 0? Well, just remember, you're taking the square root, and square roots are going to be positive unless there's a negative stuck in front of it. So your range is going to go from 0 to infinity. You can also graph this on your calculator. Is this a function? Yes, this is a function. So what about x is equal to the absolute value of y? We did this on a previous slide. There's a couple of ways you can go about this. This one's a little bit different because it's really difficult to solve it for y. You can say y is equal to x and y is equal to negative x, right? If you follow those rules for solving for y. Well, what exactly does this look like? If you pick 2 for x, let's say we pick 2 for x. 2 goes here, 2, and we say y is equal to 2. So if you pick 2 for x, then y is also 2. But what if you pick 2 here? You have negative because of the negative, but you still pick 2. So y is also equal to negative 2. So what we did was we picked 2, but we got 2 different y's. Is this a function? No, it's not a function. But what is the domain of this? What would that look like? It's actually going to be your absolute value function, but it's going to be sideways like this one. Interesting, huh? Okay, so how about number 4? We have a square root again, so the radicand needs to be greater than or equal to 0. So x plus 3 must be greater than or equal to 0. Subtract 3 from both sides, so x is greater than or equal to negative 3. This is going to be your domain. All real numbers except x must be greater than or equal to negative 3. And just like we were saying on number 2, since we're taking the square root and we're making this 0 or more, then your y will also be 0 or more. So your range is going to be from 0 to infinity. This is a function, and if you put this in your calculator, it makes this kind of shape. Have a look, see if it's true. Function notation. So let's say that this is our function. F equals the set that includes the points 2, 5, and 3, 8. You can read this as the function pairs 2 with 5. It pairs 3 with 8. You can also say f of 2 equals 5. The function at 2 is 5. So you're saying it like this. The f of 2 is equal to 5. F of 3 is equal to 8. That's how you would read that. This one is your function notation. You'll see this a lot. So given these two functions, h and f, we want to know what h of 7 is. Well, to find h of 7, you just look at the y value. H of 7 is 9. That means when x is 7, what is y? So, number 2, find w if h of w is equal to 0. Well, this time they're giving you the y. H of w is 0. So we're looking for where y is 0, and they want to know what is the x that goes with it. So that would be 6. So h of 6 is equal to 0. How about finding f of 7? F of 7 means, put it in this function. So f of 7 is equal to the square root of, wherever there's an x, you put a 7 in there. 7 minus 3. So we have the square root of 7 minus 3. That's the square root of 4, which is 2. So f of 7 is equal to 2. So how about the next one? Find x if f of x is equal to 5. Remember, when they write it like this, they're telling you what y is. So here you're going to put the 5 equals the square root of x minus 3. So that's how we find out what x is. To get rid of the square root, we need to square both sides. So we get 25 is equal to x minus 3. And then you add 3 to both sides, so you get x is equal to 28. We found x. So f of 28 is equal to 5. That's what that one means. How about you try this one, but then you need to pause the video, start it back again once you finish. See if you got it right. See if I get it right. So we want to find f of 4. F of 4 is equal to, replace the x with the 4. So we get f of 4 is equal to 1. Next one says find x if f of x equals 9. So we replace the f of x. 9 is equal to x minus 3. Add 3 to both sides. So we get x is equal to 12. So f of 12 is equal to 9. Okay, so now we change it up a little bit and throw some variables in there. What if we wanted to find f of a when f of x is this one? Well, f of a means take out the x and put an a in there. So a squared minus 2. That's all you do with that one. So do the same thing, but find f of a plus 1. F of a plus 1, remember that means take out the x. So if you take out the x, it would look like that. But in the place of x, we put a plus 1. Well, we just need to simplify that out now. That's going to be a plus 1 times a plus 1 minus 2. So, since I'm running out of room, I'll just work this one out. A squared plus 2a plus 1 minus 2. So we get a squared plus 2a minus 1. This is f of a plus 1. Do you think you can do 8 and 9? Go ahead and pause the video again. Work it and then start it back to see if we both got it right. Okay, so g of x minus 2 is equal to 2 times whatever x is minus 3. But it's telling us that x is x minus 2. So we get 2x minus 4 minus 3, or 2x minus 7. That's going to be our g of x minus 2. Finally, let's find g of x plus h. So g of x plus h is equal to 2 times x plus h minus 3. So we get 2x plus 2h minus 3. None of those are like terms, so that's pretty much all we can do with that one.